In this video, we'll be talking about completing the square. So we've talked about solving quadratics with factoring. However, factoring doesn't work for all quadratic equations. Completing the square is one method that will work for any quadratic equation. So let's take a look at kind of the governing thought here. Let's say I had the equation x squared equals 64. Well, there's two, possibilities here. So since I just have a single x and it's squared, I can undo that square with a square root. Now I have to be careful when I do that because I have to consider both the positive and the minus case. So if I'm going to take a square root of both sides, x is going to equal, and this is where the plus or minus kicks in, plus or minus square root of 64. I have to also consider that maybe it's a negative number times a negative number that made the 64. In this case, 8, since 64 is a perfect square. This tells me that x equals 8 or x equals negative 8. Now, if we're staring at an equation where we have a linear term, say we have a 3x term with our x squared, this trick doesn't work. But maybe there's some way we could add something to the equation to make what we call a perfect square. So what do I mean by perfect square? Well, let's recall back to binomial perfect squares. So this is kind of our second governing thought. If we have x plus a as a quantity and we square it, which remember, this is the same thing as x plus a times x plus a, turns out there's a shortcut. This will turn out to be x squared plus 2ax plus a squared. So this will work out every time. If you want to FOIL this out or distributive property this out, you can. It should boil out to be this. And what we're really keying off on here is our 2a and our a squared. So let's dive right into an example. So let's say I wanted to solve this equation. You might be looking at it thinking, there's no way this will factor. If I'm looking at this negative 7, there's no way that negative 7 can have its factors add up to positive 4. There's just no way. So what we're going to do is we're going to add 7 to both sides. So I'm going to have x squared plus 4x equals 7. And now at this point, I'm going to go off to the side a little bit. And I'm going to think, okay, x squared plus 4x plus something equals x squared plus 2a x plus a squared. Now what I really want to find is this a squared. I want to figure out what this is. And you'll see here in a second why that's useful. But for now, just bear with me. So if we're going through this, we know that 2a has to be 4. Since our linear terms have to be equal in this case. So this means that a is 2, which means that a squared is 4. Now just a side note, it won't always work out that these two are the same. It just so happened because a was 2, 2a is also the same as a squared. So just be aware of that, be very careful. So the idea is, set your linear term equal to 2a, solve for a, then square it. This number right here, this a squared term, this is the thing we want to add to our left side of the equation. Now, we can't just add to the left side of the equation. If we add something to the left side of the equation, we also have to add it to the right side of the equation. So what we're going to do is we're going to come back over to our blue equation, and we're going to say, okay, well, x squared plus 4x plus 4 equals 7 plus 4. And you might be thinking, well, why do we make it more complicated? I'll show you here in just a second. If we look at this left side of the equation factors now. And it's going to factor into x plus 2 squared. And I'm just going to go ahead and simplify the 7 plus 4 and make it 11. Now, if we're looking at this, this is a lot more workable. We have something squared equals a number. I can take a square root of both sides. And again, I just have to be careful with the plus or minus. So x plus 2 equals plus or minus the square root of 11. And then I'm going to subtract 2 from both sides. So x equals negative 2 plus or minus the square root of 11. Now, square root of 11 is not a rational number, so I'm just going to leave it as the square root of 11. Now, what this means is that I have two solutions. X equals negative 2 plus the square root of 11, or x equals negative 2 minus the square root of 11. This last step is kind of redundant. The or is kind of baked into this first little bit with the plus or minus, but this is what it means. So just kind of clarifying what it is. So this is kind of a weird example, but this whole process of going through, figuring out what your A has to be, figuring out what this magic number is to add to the other side of the equation. And that is completing the square. You're not so much completing like an actual physical square, you're completing a square expression.